Good morning, good afternoon, good evening, class. This is Mr. Arosena, and today we are going to talk about product rule and quotient rule of derivatives. Product and quotient rule for derivatives. Okay, because earlier in this series we had talked about power rule and how it applied to polynomials. Today we're going to talk about product and quotient rules and how this applies when we multiply and divide functions and how we find the derivatives of that. Alright, so quick recap. Power rule stated the following. If f of x was x to the n, then f prime of x is equal to nx to the n minus 1. And if I had f of x plus g of x, then their derivative, d dx of f of x plus g of x, was really just f prime of x plus g of x, or sorry, g prime of x. And this was true if this was a subtraction of functions as follows. So what we talked about in previous lessons. Now today we're going to talk about what do we do if we have the following. Okay, so suppose I have two functions. So suppose I have two functions, f of x, and we're multiplying it to the second function, g of x. What is their derivative? What is d dx of f of x times g of x? Okay. Well, a little background on Leibniz first thought about this. He thought that this would equal just the derivatives multiplied by each other. Because if the derivatives for addition and subtraction were just the addition of the two derivatives, he felt, well, the products might be the same. But it turns out that this is not true. So this is completely untrue. Okay. It's a little bit of work, and using the definition of the derivative, which is what we are going to do today to prove this, to prove what this is equal to. We'll go back to our definition of the derivative, which was the limit as h goes to 0 of f of x plus h. And since our functions are being multiplied together, we'll do g of x plus h. So f of x plus h times g of x plus h minus f of x times g of x. And this is all over h. Okay, from here, it looks like there's not much we can do, at least as we've written it here. So I'm going to be a little clever with our algebra. I'm going to do the following. Limit as h goes to 0 of f of x plus h times g of x plus h, and I'm going to subtract the following. Subtract f of x plus h times g of x. And if I subtract this, I have to add it back in to maintain this sort of addition by 0. So technically I haven't actually changed anything, because I'm just adding and subtracting the exact same things. This is one algebra technique we call an addition of 0. Okay, now why am I doing that? Well, as I set this up, take a look at the numerator of this equation, and you should see something really interesting. From the first two terms, I can take out, oops, that's a horrible color. Let's use a different one. I thought it was one red. Okay, so there, we can take, the first two terms have an f of x common in them, so I can take that out. So I'll take that out, f of x plus h. Okay. The two terms after that have a g of x common, so I can take out a g of x from that one. Okay, so when I do this, this first term ends up becoming g of x plus h minus g of x, and this term ends up, we'll put a plus there, this term ends up becoming f of x plus h minus f of x as follows. Okay, and then I'm going to since this is an addition, I'm just going to break this up into this, and I'm going to break this up into this. And again, remind ourselves this is actually a limit. Alright, now because this is a limit, I can actually break this up and I can put another limit here to remind ourselves that this part is also a limit. Alright, now looking carefully at these two, notice that the limit as h goes to 0 of this part, this is really just g prime of x. Okay, the limit as h goes to 0 of this part is really just f of x. Okay, here the limit as h goes to 0 of this is f prime of x. Okay, and the limit as h goes to 0 of g of x, well, that's just g of x. And lo and behold, this is what the derivative of f of x times g of x happens to be. This wonderful equation here, this is the product rule of derivatives. Product rule of derivatives. Okay, I'll just refer to it as product rule as we work through this chapter. Product rule of derivatives. Okay, there we go. Now, on to quotient rule. Quotient rule is going to be slightly more complicated. Well, we're going to use this definition of derivative for a quotient rule. So quotient rule basically says what happens if I take f of x and I divide it by g of x, then what is the derivative of this? Derivative of f divided by g. Okay. Well, obviously it's not going to be this is not going to be f prime divided by g prime, because we saw in our previous one that the product is not f prime times g prime. So the quotient is not going to be f prime divided by g prime. So what we're going to do, go back to our handy definition of limits. Or not limits, sorry, definition of derivatives, my mistake. And we're going to write the following. Yeah, I'll write it like this for now. F of x plus h divided by g of x plus h minus, close bracket, f of x divided by g of x, all divided by h. Okay, now to help us to keep the bookkeeping a little easier, and so I'm not working with a bunch of fractions, I'm going to factor the 1 over h out here as follows. Okay, oops, not 1 over 2, 1 over h. And then inside, this leaves me with f of x plus h divided by g of x plus h. I am going to leave a bunch of space, because we're going to be doing a lot of things to this, minus f of x times g of x. Okay, so like with any fraction subtraction, I'm going to want to put this over a common denominator. So in order to do that, I'm going to put a common denominator. Okay. In order to do that, I'm going to have to multiply this term by g of x. And I'm going to have to multiply this term by g of x plus h. Whoops. G of x plus h. Okay, by doing that, I can now write this all over the same denominator, which happens to be, move this g of x over. So they're all over the same denominator, g of x. Okay, now why did I leave myself this huge space here? It's because I want to add and subtract something. Okay, very similar to what we did with the product rule proof. So I'm going to add the following. So here it looks kind of like we have an f of x plus h here. So I'm going to subtract from this one f of x times g of x. Okay, and it might become obvious why I'm doing this. If I subtract this, then I have to add the exact same thing on the other side. Okay, so much like before, there should be some interesting things you should notice. For one, the first two terms have a g of x, and the second two terms both share an f of x. So now we can rewrite the numerator. Okay, rewrite the numerator. Let me select the blue as follows. So limit h goes to 0, I have 1 over h. The first two pairs, we pulled out a g of x, so I'll write that in red, sorry. Write that in red, g of x. And we are left with f of x plus h minus f of x. Okay. And this is, well, I'll leave that out for now. And then we're going to have a plus. And we've pulled out an f of x here, so plus f of x. And then inside we're left with g of x minus g of x plus h. Like that. And this is all over g of x plus h times g of x. Alright, bear with me. We're getting there. Okay, I'm gonna swap these two out. Okay, those two are gonna swap out. It's easy enough to do that. Just an algebra trick. Okay, so I'm gonna put 1 over g x plus h times g of x on the outside. Okay. In here, I'm left with a g of x, and then I have f of x plus h minus f of x. Should be pretty obvious why I did that switch. I can put that over h, which is exactly what I want, because it should be obvious why I did that. And if not, just think about it. What does this part look like? Okay, and this will be f of x times g of x minus g of x plus h all over h. Okay, and it should be pretty well, maybe not obvious, but it should be somewhat clear why I decided to write it like this. Okay, and why I broke up that addition of fractions to look like this. Okay. All right, this portion here, I'll highlight it here. This portion here, if I remembering this is a limit. Okay, as h goes to 0. This portion here is really just f prime of x. Okay. G of x remains g of x, because as h goes to 0, g of x doesn't matter. It's effectively a constant, so it stays g of x. Okay. Now over here, this one looks a little more interesting, because notice it's g of x minus g of x plus h. What we really want it is to be g of x plus h minus g of x. So what I can do is I'm going to factor out this negative sign. What that does is it changes this. It will change. So I'm just going to... Oops. It will change this to be this. So it changes that to be g of x plus h minus g of x. And because I factored out a negative sign, it'll change that into a negative. There we go. Now by factoring out the negative sign, I now have this portion, which looks exactly the same as g prime of x, when I remember that I'm really taking the limit as h goes to 0. Limit as h goes to 0 of f of x is really just f of x. Okay, and now we're left with, what do I do with this portion? Well, if I take the limit as h goes to 0, this portion really just becomes, 1 over g of x times g of x, or 1 over g squared. Okay, and normally we don't write it as 1 over g squared times this. Normally we just write it like this, times g squared. There we go. This is the derivative d dx of f over g. And this handy rule here is what we call the quotient rule for derivatives. This is the quotient rule for derivatives. Okay, so I've got quotient rule and we've got product rule. Let's use them. We'll go through an example of each. Example 1. So, using product rule, let us differentiate or find a derivative. Differentiate, let's say, x squared plus 4x cubed times 3e to the x plus x to the negative 4. Alright, so I'm going to call let's call this f of x, and let's call this g of x. Okay, so the derivative d dx of f times g is, again, if you remember, f times g prime plus g times f prime. So f of x is just the first function, so x squared plus 4x cubed. Then we multiplied by the derivative of g of x. That was g prime, so we just take the derivative of this. So the derivative of 3e to the x, well, this is just going to be 3e to the x, remembering that e to the x is its own derivative. And then we're going to add this to the derivative of x to the negative 4, which is going to be negative 4x to, and then we bring the negative 4 down, just because, and then we subtract 1 from it, so it becomes negative 5. That's the first part. Then the second part is g, so 3e to the x plus x to the negative 4 times the derivative of f of x. So in this case, the derivative of f of x will be derivative of x squared, which is 2x, plus the derivative of 4x cubed, which is going to be 12 times x squared. There you go. There's our derivative. We could simplify it if we wanted to, but unless the question asks you to, this is actually perfectly acceptable. But again, simplifying it is just a bunch of algebra after this, so I'm not going to worry about that. The important thing is, can I remember this? Okay. All right, let's differentiate using the product or quotient rule this time. So example 2. Differentiate following function. Let's say I have square root of x divided by 1 plus x squared. I'll use that. Okay. So according to our rule, our product rule is as follows. G times f prime minus f times g prime, all divided by g squared. So first, g is the function on the bottom. So this function is g of x equals g of x. Okay, g of x is not 1 over 1 plus x squared. G of x is just the function that's inside the denominator. So g of x is 1 plus x squared. 1 plus x squared. F prime, this is f of x. So we take the derivative of square root of x. Recall that square root of x can be written as x to the 1/2. So f prime would be 1/2 times x to the, so 1/2 minus 1 is negative 1/2. So this would be 1/2 x to the negative 1/2. Okay, minus f is square root of x, times g prime. Well, g of x is 1 plus x squared, so we take the derivative of that. Derivative of 1 is 0, plus derivative of x squared, so this would be 2x. And this is all over 1 plus x squared, all squared again. And there you have it. There's the derivative of f divided by g. Okay. And again, I don't think we need to simplify any further than this. Okay? Again, unless the question asks you to simplify, in which case it's just a bunch of algebra. So watch your algebra, watch your exponent rules. All right. That does it then for just two quick examples of product rule and quotient rule of derivatives. Okay, and to recap, product rule is d by dx of two functions multiplied together is going to be f times g prime plus g times f prime. And then quotient rule so d derivative of f divided by g is just g times f prime, not plus, minus f times g prime, all divided by g squared. Alright, remember those rules? They'll be coming quite handy as we talk about more and more derivatives later this chapter. Alright, good luck, and if you have any questions, come see me in class.